um, what are the different types of forming the clusters. So that we shall see. Um Initially, first for 5 minutes or 10 minutes, we shall discuss what actually is the clustering concept is. And before that, we already know that we have seen the classification, and the classification we also call that as supervised learning. So this supervised learning, why we call this is when we take a database, and in that finally what we want is the final output. What actually we want is, if a record is given, and for that record, if one particular attribute has to be found, then after your classification we will get the result of what that attribute value is. The same, instead of classification, we can also call that as the prediction. So what we will be predicting is the value of the attribute, and we call that attribute to be as the class label. And because we already know the value of the class labels of all the training data, we call that as supervised classification or supervised learning. So what is this um, clustering is? What we call this clustering is grouping the similar objects. Simply, with simple statement, we call this clustering to be as grouping the similar objects. So if we are given 1,000 objects, and if we want to find three groups out of the 1,000 objects, so we call that, like we say that we have obtained three clusters. So how to obtain these clusters is one parameter. That keeping aside, what actually we want is this um, simple definition, as I said, like grouping the similar objects. What is the necessity of going for clustering? Why we have to analyze the clusters? What is that we are going to achieve with the data mining of the clustering? What is the necessity? So if we take, say, for simple example, if we see the classification, we have seen some examples like prediction. We have seen some examples like, if you go for the Bayesian classification, in that Bayesian classification we are saying that if these symptoms are there, this particular disease is going to come. So in a similar way, clustering where we can apply the clusters is, if, say for example, if your Yahoo page is there, in that Yahoo page, we know, like, every day some millions of customers, they will be, just hold on a minute. So if you take millions of customers or millions of uh, web clicks will go on a Yahoo page. So finally, at the end of the day, when I if I ask the question, how many customers are interested in the news, how many customers are interested in movies, how many customers are interested in sports, so I should get an answer. So here the three clusters what I'm trying to form is one cluster who are interested in movies, one cluster who are interested in movies, one cluster who are interested in news. So three clusters I got, and the application what I want is which customers are similar, so that, like, I can get an analysis on the web page, Yahoo web page, which cluster is having more objects, so that they are interested in the movies, which cluster is having less objects, which means that the customers are not interested in that cluster. So that is the final analysis I would like to predict what is happening in that particular page. Similarly, if I take a Spencer shop, or if I take any Reliance, if I say, like, which customers are similar, or if I ask what are the items which are similar items, what are the items that can be grouped together. So I have to find out the distance between the items, so that I need to group the objects whichever items are very nearer together, whichever items are nearer, I would like to form those items as clusters. So here the final what is the application of the clustering is, you need to identify the objects which are similar, which are nearer to each other, which are having the similar properties. You need to form a group out of those objects. What is the practical application? How to form the groups is, how do you say that those particular two objects are similar means, practically in real time, what is the similarity measure you need to find. So what is the similarity measure means here, in the similarity measure you need to find the distance between two objects. So how do you find the distance between two objects is, if you have the idea of the distance formulas, whether you take the Manhattan distance, whether you take the Euclidean distance, whatever you take, if you can identify the distance between those two objects, then you can find out which objects are having less distance, which objects are having more distance, and based on that distance, you can find out which are similar and which are dissimilar. So if you form a cluster, if you take two clusters, it should be like the objects in one cluster should be similar and they should be dissimilar with the objects in the other cluster. So that is the final formal definition, the application, and what we have to do. These are the 3 points. And I see Janani and Durga, they are writing the notes. It's good that all of you better write the notes. You better write the notes, and yeah, in a minute I will share the textbook as well as some of the slides. Mm, can you see the screen?
Yes,
Yes,
madam.
ma'am.
Yes, madam.
Yes.
Yes, ma'am.
Yes,
So
madam.
enough. Okay, if you see this clustering concept, uh, we can see like different methods are there in this clustering. So in this different methods, which means that they're categorized the different methods. Partitioning is one method, hierarchical methods, density based and grid based methods. We will see two sub methods in these methods again. So in the partitioning methods, the famous two algorithms you have is k-means and k-medoids algorithm, which partitions your data. So if you take a set of data objects, we will form the clusters by partitioning the objects. So the objects, whenever I say the object, you refer the objects or think of the objects to be as they are nothing but the record. So if you take a table, one row represents one record. So that row or the record, we call that to be as the object. So if there are 1,000 records, we take them as 1,000 objects. So here the partitioning method means we try to partition, or we try to divide the objects and then see which objects are nearer based on the distances, based on the distance between the objects, we try to form the clusters. So this is your partition methods, and in this partitioning methods we will see k-means and k-medoids. K-means is very famous algorithm and very important algorithm when we come to partitioning methods. And similarly, you do have the hierarchical methods. So in the hierarchical methods, we try to form the clusters based on the levels of the objects. So when you form the groups, when you form the clusters, they are formed based on the levels of the objects. So we try to take some parameter and find the distance again on that parameter and try to form the dendrograms. So what these dendrograms, or what these dendrograms, nothing but they are the tree structures. So we shall see like what those hierarchical methods are. we call like two methods in the hierarchical methods we will see are agglomerative and divisive algorithms. And we do have the density based methods. So if we have lot of objects, if we have so many crowded objects are there, so overcoming the drawbacks in the partitioning and the hierarchical methods, we will go with the density based methods, which are having more advantages than the partitioning methods. So in this we will see a DB scan and optics. And grid-based methods, we did not include the grid-based methods, but they are of course similar to that. And we try to segment the objects and then form the grids out of it and take out some grids as the clusters. This is what your 4 different types of clustering we can say. So in that 4 different types: partitioning, hierarchical methods, density-based methods, and grid-based methods. Now I repeat: partitioning, under partitioning, k-means and k-medoids. Agglomerative and divisive will come under hierarchical methods. DB scan and optics will come under density based methods. And scaling or some other method is there under grid based, and we are not covering the grid based. And another synonym for the clustering, we even call this as segmentation clustering. So what is this segmentation or clustering? Data segmentation, we call that as. So in the data segmentation, it is nothing but again where do you cut the data and again group them. So in that case, we call this as a data segmentation. And this is also called as automatic classification. More than the automatic classification, this is also called as unsupervised learning. Unsupervised learning is very, very important, I should say. Unsupervised classification. Why? Because very important thing you should say is unsupervised classification. In the sense, I mean to tell that you will not have the class attribute or the class label in the data what you take. This is totally opposite to your classification concept, where in the classification concept you do have one attribute as the class attribute or the class label, which you will not have in the clustering. So what is this class label or the class attribute is, that is the one we will predict in the classification. So what is that we are going to do with the automatic classification is, though you does not know what is the class label, after you form the clusters, then you will identify what that particular group is. So if you identify what that particular group is, means it is nothing but you are giving the class name to that cluster. So which means that at the end you are finally giving the class name. So because you are giving at the end without knowing what class it is, you are naming that class. After the entire clustering is over, you call that as unsupervised classification. We does not have any supervision when we are doing the classification. So in the process of doing the classification without supervision, you call that as unsupervised classification, and that is called as the clustering concept, which is opposite the same work. Actually at the end you are trying to predict something. Even in the clusters also you will predict, but the outputs we differ a little bit. Is in the classification you simply predict which class it is. In the clustering you simply give how many clusters they are, but finally they both are linked. Like we should say that the concept is simple and the same. Either in the classification or the clusters, you end up with the classes, you end up with the number of classes. That's all. So only the thing, this clustering, it is called as unsupervised classification, because we does not know what classes are going to be formed, what class name we should give to that group. At the end you give the name to that cluster or the group, which you call that as the class, and that is what we call this as automatic classification or the unsupervised classification. Simple thing, the simple what we shall see with an example in the partitioning methods. Yes. Simple thing. If you see this figure here, initially, like, these are the objects. When I say this particular dot, this represents an object. So if you, as I said, like, if you take that object to be as one record, and where that record has number of attributes, how do you represent this particular object is among, say for example, if in that record you have 10 attributes, so in that 10 attributes, if you have the name, if you have your roll number, if you have your mail id, your age, your date of birth, your address, and so on, you pick the two attributes, because this is a plane, this is a 2D, and you are representing an object here. So you pick an object, you pick two attributes where you can represent that two attributes with a point. So in a 2D plane, if you take this object to be as a point, in the sense you are having two coordinates for that. I don't know, some of you please mute your system. Who is that? Sai Krishna. Mute your system. So if you take the object in such a way that this object represents two attributes in the record what you take. So when I say this object represents the complete record. At the same time, here in this picture, you take this object to be as only two attributes, where that two attributes they represent to be as a point. Let me see. If you take, yeah, if you have the name, if you have your roll number, if you have your gender, your address, your email, your phone number, your age, your height, your weight, if you have the attributes, all these are the attributes describing you, you take the two attributes in such a way that which will represent, which are having the numerical values, that is the first thing, which are having the numerical values, and you take a point where you take the two attributes to represent as a point. So name, if you take, it will be like this, and if you take something, your roll number will consist of the characters and the attributes, and if you take your gender, it will be like this, and address, if you, again, if you take something, your mail id will be like this, and your phone number, some number, and if you take the age attribute, maybe something like your age attribute, and if you take your height, something like 5.6, and if you take your weight to be as some 55 something. So if these are the values you give, now you have to take the attributes in such a way that they represent one point. So x and y, so they represent one point means obviously and definitely you cannot take the characters to be as the attributes to represent the points. So you have to take the values inside this, either the age or the height, or the height or the weight, or the age or the weight. This to the any of these two attributes among three, you select only two where you can represent that to be as x and y. So in that x and y, if you take age, if you take on x-axis, and weight if you take on y-axis, a point on that represents x 22 or 55. So age and the weight. So that is the point you represent. So that is what this individual point represents in this clustering. And what happens here is, in the k-means, like partitioning methods, the first algorithm we call that as k-means, where your k represents the number of clusters, how many you want. K represents the number of clusters. K represents the number of groups you want. So the clusters here, initially you have to give how many clusters you want, and randomly initially you take the initial clusters in this way, and then you have to apply the logic. When you're applying the logic, your boundaries will change, your cluster boundaries will change. So cluster boundaries will change in the sense the objects in one cluster in one iteration will come into the another cluster in the second iteration, and in the third iteration that particular object will go into another cluster. So how this will go, why this will go, is the logic of your k-means that we will see in just a while. And uh, sir, I'm in an online class, sir. I'll call you back. Huh? Okay, sir. Yeah. So what we will see here is you have to keep on going the iterations until the objects does not move into the another cluster. So in the initial clusters, your objects will move from one cluster to the other. In the sense, objects will be like that only. Your cluster boundaries and your cluster shapes will move, and you have to go for the number of iterations until your clusters does not change their shape anymore. That is what your k-means algorithm is. How and what we will see just in a while. So the basic initial the sketch or the outline of simple logic is, first initially you will take, because I want three clusters where I have to tell the input k as 3, randomly take 3 points as your cluster centroids. So you take like this and find the distance from all the objects, and take, if you can keenly see the points here, this is one centroid, this is another centroid, and this is another centroid considered here. Now, taking this centroid, find out the distance from each and every object in this complete space, and take from this object, you take the distance from all the objects. Now you find out which object is nearer to the other. So if you take this particular object and this centroid and this centroid, you find out the distances of all the objects. Now you change the centroids by considering which objects are nearer to this one. Finally, compute your centroid. Now computing your centroid, now it has changed its position. So centroids have come. Small dotted ones are the new centroids, which are new clusters which are obtained in the second iteration. Now again find out the distance from this centroid to all the points. Now again change the boundaries. This algorithm is a kind of PDL, your program description language. It is not the complete algorithm with all the mathematical terms, but the simple English. For any algorithm, you have to tell what that algorithm is, what is the input, what is the output, and the method. Especially with respect to this particular textbook, these are common for any algorithm, whether you go for classification or pattern matching or the clustering. So this is the k-means algorithm. What is the input is, as I said, like k is the number of clusters. You have to specify how many clusters you want, and d is nothing but the complete data set. So the complete data set is nothing but how many objects you are considering. So the total number of n objects are there, and that you are keeping in a d. So final output, what you want is, the final output is k clusters, the number of clusters you will be getting, which indicates that in each cluster which objects are there. That is the output you have to find out. So the first step here is arbitrarily choose your k objects from the d as the initial clusters, and then what you have to repeat is, considering this each object, find out the distances. So whichever object is similar or most similar, form them a group, and to that group find the centroid. So update your cluster means or the centroid, both of them mean the same. So calculate your mean for the objects for each cluster until no change is there. That we have to repeat this one. Though you understand or not the repeat logic part, just keep it aside. After the numerical example, we will come back to this algorithm again. But initially, I hope You have understood what the k-means algorithm is, what is the input we have to provide, and what is the output we will be getting. And what I wanted to know is, as of now, just raise your hands. How many of you have just understood what is the clustering, what is what are the applications of it, how we will be doing this, how we will be doing the details we will go later. But as of now, did you understand the basic definition of what is meant by clustering? Just raise your hands without audio. Just raise your hands. Yes. Okay. So as we are going now is the different types of clustering also you have seen. Yes. Okay. Okay. Enough. So different types of clustering we have seen, and the simple example what I will be telling. If you're, not if, all of you take this numerical example which is not there in your prescribed textbook, which is very simple and with which you will understand the complete what actually is k-means algorithm is. Yes. So what is that we will be seeing in this example here is, this is the database given. This is the database D, and 4 medicines are given, and these are the medicinal values or the attributes. One is having the weight, and the one is having the pH value. You should understand the database for any sort of data mining functionality. First thing what you should understand is the complete database. You should understand, what the attributes are, what they're telling about this object. So with this database, what I can tell is, there are 4 rows, in the sense there are 4 objects, and 2 attributes are describing each object. So what are the 2 attributes describing each object is, medicine A is having the weight index of 1 and the pH value is 1. Medicine B, the attribute weight index is 2 and the pH value is 1, and so on. So which means that here these 4 objects are the input, and the attribute values are also inputs. What is the final output? What I want is, better all of you take this table also. What I want is 2 clusters out of these 4 objects. 2 clusters, 2 groups. What are the 2 groups I wanted to know is, among the medicines A, B, C, D, which medicines are similar? Which medicines are similar in 2 groups? Are you able to follow? Just raise your hands. Yes. Okay. So what we are seeing here is, final output what I want is, among the 4 medicines, I want, if my k is equal to 2, I want 2 clusters in which I have to set these medicines so that each cluster has the similarity among the medicines. Now I hope I am clear. Okay. Now, so in this, if this is the input, because I said my k value is equal to 2, you take randomly 2 objects as the centroids. So if you take medicine A, what you represent this medicine A is as 1, 1. So if you take this x and y, x axis I am taking weight index, and y axis I am taking pH value. So the first medicine here, what I'm taking here in my first medicine is, this is 1 comma 1, 2 comma 1, 4 comma 3 and 5 comma 4. So this is what my representation is: 1 comma 1, 2 comma 1, 4 comma 3 and 5 comma 4. So these are my objects representation on this plane. Because this is 2D, I have taken two attributes. I am representing that on x and y axis. And because I want my k is equal to 2, randomly I have taken two objects as my centroids. So two objects means here, this is medicine A 1 comma 1, medicine B 2 comma 1. These two I have taken as my centroids. Now what I should do, what is the next step I have to do is, the first step what I have taken is, randomly I have taken the objects to be as the centroids, and the number of centroids I have given as input, which is nothing but the k value. So because I want k is equal to 2, I have randomly taken. It is not that you take medicine A and B always your centroids. You can take medicine A and medicine D as the centroids also. Now, what is the second step I have to do is, from this particular object, find out the distances from each object. So find out the distance from medicine A to medicine B, medicine C and medicine D. Find out the distances and keep it in a distance matrix. And again, after that, find out the distances from medicine B, this is centroid 2, C2, to medicine A, medicine C and medicine D. So find out the distances. Now after you find out, if you take medicine A, you find out the distance from medicine A to medicine A. The distance from medicine A to medicine A, what is that distance? So obviously this distance will be, from this point to this point means the distance will be 0. Now this point to this point. Now from this point to this point, you have to identify this distance and this distance and make this object to come into this cluster if this distance is lesser than this distance. And similarly, find out the distance from this point and again the distance from this cluster, and group this object into this cluster whichever is nearer. After you form that, find the new centroids. So ante, if for example, if you see this one, this particular centroid is nearer to this than this one. So now in the second iteration, for these three objects, you find the centroid. So for these three objects to find the centroid, obviously your centroid will come somewhere around here. Obviously in the second iteration, your point will come here. Okay. And then again, find out the distances. So finding out the distances, calculating the centroids will go into the loop, will go into the iteration. And this iteration, Nana, please don't disturb like this. Mute your systems. BVVSV Prasad. Mute your system. So if you take these points, finding out the distances, calculating the centroids, finding out the distances, calculating the new centroids. These two steps will go into the repeat loop. And how long they should go is, you have to stop until the objects are being in the same cluster. They are not moving. In the sense, your centroid will have the same points even if you go for the next iteration also. Until that point, you have to keep on iterating. So that is what the algorithm is. So after find this, so find out the distances. That is the next step we have to see. All of you take this one, take this. Here I have taken Euclidean distance, but you can go with any sort of the distance based on the attribute values you have. You can even go for the similarity distance. You can even go for the Manhattan distance. And what else are there? There are some other distances which will find the distances, some other formula, but simple one is square root of y2 minus y1 whole square plus x2 minus x1 whole square. So you can keep that in the distance matrix. So with respect to 1 1, with respect to 1 1, the distance from 1 1, distance from 2 comma 1, and 3.61 is distance from, I think, this one 4 comma 3. So 4 comma 3 comma 1 comma 1, this is the distance. And the distance from 5 comma 3, I think, and this is the point 5 comma 4, distance from 5 comma 4 to 1 comma 1, this is the centroid one. So these are the square root of y2 minus y1 and that for formula. Please raise your hands if you understand that first first row. Yes, yes. Okay, 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 okay. Yes. Okay. Yes. So how did you get this first row is the distance from 1 comma 1 to all the remaining points. Now second row, how did you get for this matrix is distance from centroid to 2 comma 1 to all the points. So all the points it is, this is 1 comma 1, this is 2 comma 1, 2 comma 1 to 2 comma 1 is 0, this is 3 comma 4, and this is no, what is this, 3 comma 4, and this is 5 comma 4. That is what I think. What is the third point? 4 comma 3, not 3 comma 4, 4 comma 3 and 5 comma 4. So that is the, those are the points and the distances. Now what is the important point you have to observe here is, now this is what you call this as distance matrix, and from this is the points 2 comma 1, 4 comma 3, 5 comma 1, these are the points. How did you get this differences? Yeah, it is given in the slide, I didn't observe this. Okay, after you get this, then if you say this 0 comma 1, you take the values among this matrix, you take the values whichever are having the minimum value as 1. The minimum value means here, if you take 0 comma 1, this is the minimum among 0 and 1, and if you take 1 comma 0, this is the minimum, and among 3.61 and 2.83, whichever is minimum, so you take this as 1 and this as 0, and 2.83 is lesser than 3.61, ante your C is nearer to C2 than your C1. Similarly, among 4.24 and 5, your 4.24 is lesser than 5, which indicates that your D is nearer to C2 than your C1. I hope you understand what I'm saying. This is what you do. And a group matrix, you call this one. How you're forming the group is, whichever are having the minimum distance, you take that as 1, whichever are having maximum distance, you take that as 0, so that we find that here in group 2 more ones are there, indicating that all these points are nearer to C2. This is our C2 and this is our C1, and this is the group matrix. So in the group 1 you have only one object, and in the group 2 the remaining all B, C, D points, they all belong to group 2. So ఇప్పటి వరకు what did you understand here is, you have found the distances. అంటే నేను డిస్టెన్సెస్ ఒక్కటే ఫైండ్ అవుట్ చేశాను ఆఫ్టర్ ద ఇనిషియల్ సెంట్రాయిడ్ పాయింట్స్. నౌ వాట్ ఈస్ మై సెకండ్ రిపిటేటివ్ పాయింట్ ఐ షుడ్ డూ ఇస్ ఫర్ ద న్యూ గ్రూప్, ఈ కొత్త గ్రూప్ కి ఫైండ్ ది సెంట్రాయిడ్. సో ఈ వచ్చిన కొత్త గ్రూప్ కి ఇనిషియల్లీ యువర్ సెంట్రాయిడ్ ఈస్ హియర్. ఇప్పుడు ఇక్కడ నుంచి టు ద న్యూ పాయింట్స్ విచ్ ఆర్ బిసిడి, ద న్యూ సెంట్రాయిడ్ వచ్చేసరికి ఇక్కడ వస్తుంది. సో యువర్ సెంట్రాయిడ్ ఈస్ నథింగ్ బట్ యువర్ యావరేజ్, యువర్ మీన్. దట్ ఈస్ వాట్ దిస్ కే మీన్స్ ఈస్ కాల్డ్ యాజ్. మీన్స్ అన్న, యావరేజ్ అన్న, సెంట్రాయిడ్ అన్న, ఆల్ ఆఫ్ దెమ్ మీన్ ది సేమ్. సో ఇప్పుడు ఈ పాయింట్స్ కి అంటే what is this one, 2, 1, this is 4, 3 and 5, 4. ఈ మూడిటికి అంటే 2 + 4 + 5/3 and 1 + 3 + 4/3. that will give this point. అంటే ఈ పాయింట్ నేను అనుకోవడం this is like 3.6 to 2.7 or 8 something. That is your centroid will be, I don't know whether he has calculated. Yes, ఇదే. ఇప్పుడు వచ్చిన కొత్త C2 ఏంటి అని అంటే 11/3, which is nothing but your something like 3.6 or 3.7 and 8/3. This is almost nearer like 2.7 or 2.8. That is nothing but this point. ఇది ఈ పాయింట్ 3 something and ఇక్కడ కూడా 2.5 దాటిస్తుంది కాబట్టి 2.7 or 8. That is what this point is. And this is the new centroid I have obtained. So ఇప్పుడు again what you will do is with the new centroid find out again the distances from all the points, each and every point. Now A నుంచి distance to C11, now A నుంచి distance to 11/3, 8/3. So 11 to 11 distance will be 0. 11 to 11/3 and 8/3 distance will be 3.14. I hope you all are following. Instead of 11/3, you can simply take this one as something like 3.8. You can take this as 2.8 or something. 3.8 and 2.8 you can take in that way. Now distance from 2, 1 to 1, 2, 1 to 11/3 and 8/3, that is 2.36. Similarly these two values, please take these values. So what we have found now here is the distances. This is d power 1, already d power 0 is over. Now again we have to find out the group matrix. So what is the group matrix is, find out whichever are having the minimum values and mark them as 1, whichever are having maximum values mark them as 0, so that you will know which objects are in which cluster, which indicates that which objects are nearer to either C1 or C2. So if we take this one, now see here the group has changed. Now in this, because if you take this one, now 1 is minimum than 2.36. So here you will get 1 and here you will get 1 down. So which indicates, this indicates that CD now has come into group 2, AB has come into group 1. So now if you see this one here, CD they are in one cluster and AB are in one cluster. Now what you have to do is, for AB find out the new centroid. So that is why your centroid has come into middle here. Now here again find out the centroid for C and D. So for the C and D, your centroid has come to this point. So obviously this is what your centroid is. AB 1 + 2/2 and 1 + 1/2. Similarly CD 4 + x coordinates by 2 and y coordinates by 2. This is what your new centroid, 1.5, 1, this one, and this is 4.5 and 3.5. So this is 4.5 and this is 3.5. These are the new centroids. Now after you form the centroids, now again what you have to do is find out the distances. Now this is d power of 2. So the distance is from 1.5 to 1 and 4.5 and 3.5. So to all the points. So the distance from 1 comma 1 to 1.5 comma 1. So this is 0.5. 1 comma 1 to 4.5 and 3.5. This is this. Similarly with all the points. Hope you are taking this numerical formula. This is very, very, very important, which will let you know the complete picture of what is k-means. Yes. Now again find out the group matrix. This is the distance matrix and the group matrix. So whichever are having the minimum values, take as 1 and the remaining as zeros. So if you take this, the group here obtained is AB into one group and CD into another group. So which means that you are in the previous iteration, your G power of 2 and again your G power of 1, both of them are in the same values. So in this iteration 2 also, these two, like previously in G power of 1, that is the group we have obtained 1 1 and CD, and again in G power of 2 also we got the same values. So which indicates that your group matrix in the previous iteration and in the current iteration, they are the same. So finally what we can tell by seeing this is CD is one cluster, AB is one cluster. So two clusters have formed. AB is one, cluster 1 is AB medicine, cluster 2 is CD medicine. That is what your k-means algorithm is. So what is the group here? The final group we have obtained here is AB belongs to cluster 1, CD belongs to cluster 2. This is what your k-means algorithm is. Now we will come back to, yes, this is the algorithm. What we are repeating here is after we choose the random initial clusters, assigning object to the cluster to which object is most similar, which indicates that this is the group matrix. And update the cluster means calculate the mean value of the objects, which is the distances you're finding out. So these two are repeated until no change with the previous iteration. This is what your k-means algorithm is. Finally, we will end up with the number of clusters, how many we want, and what are the objects in each cluster. Please raise your hands, those who are with me. I don't find so many, they're not responding anything, many people. And those who are not listening to the class or those who are not interested, please leave the class. Those who are not interested, you can simply leave the class. No one asks you because these are the last classes. Attendance also is closed. Don't sit for the namesake. I can see only few hands. Half of the people have not raised their hands. Tafil, are you there?
Yes, ma'am.
Are you following what I'm saying? Did you understand?
Yes, ma'am.
But I don't see you raising your hand. What I'm saying is, if you understand, please raise your hands. That is what I say. Okay. Yeah, you can down your hands. Okay. So this is what your k-means algorithm is, and there are some drawbacks in the k-means, which says that in the K means there are if there are some points where they are very far from the set, that single point, whichever is far, will give the different shape of the cluster. So, which indicates that if you take these points here like this 1, 2, 3, and 8, 9, 10, where if you these are all very nearby, and 1, 2, 3 is very nearby, and if you take 25 and keep it in somewhere here, this 25 will affect the mean of this 8 comma 9 comma 10. So though this is extreme point, this is totally changing the centroid of the cluster. So for that purpose, your K means will affecting the total entire cluster by considering the extreme points. So where you have the outliers will affect the K-means clustering. That is the drawback of your K-means clustering, because the outliers are influencing the clusters to be formed. So to overcome the drawback of your K-means, we are going for another partitioning algorithm which is called as K-midioids. So the K-midioids algorithm is the one which will not consider any centroids, but it will try to consider each and every point to be as the representative point instead of calling as the centroid in the K-midioids, that is called as representative point. So every point will be considered as representative point and tries to find the distance from that point to the other point, and whichever point is nearer, then you can change that to P as the representative point. So total simply what we can say is simple thing, in the K-midioids you simply take or you simply categorize the objects into two, the representative point and the non-representative point. The initially what you take or what you consider is, you take any point to be either as the representative or the non-representative point. Now these representative points here in the K-midioids, you call them as the seeds. You call them as the seed points, seeds. What is the logic? What you will do in this K-midioids is, considering the representative point, you find out the distance from this representative point to all the other points in the database. So whichever points are there, you find out the distances. Now if you find any of the distance is lesser than the representative point and the non-representative points with respect to any point, then you change or you replace the representative point as non-representative and non-representative as representative point. Now again I repeat again. What you will do in the K-midioids is, you randomly initially take some points as representative points, which means that they are similar like centroids in K means similar, but we will not bring the concept of centroids here, but randomly take those points as the initial representative points, and we think that the remaining points are nearer to these representative points. So among the among the remaining points, you take all of them as the non-representative points. So if you have 10 points, take 2 or 3 as the representative points based on the number of clusters you want, and the remaining as the non-representative points. Among the non-representative points, take 1 point and find out the distance from this representative and to the remaining all other points. So if you find that the distance from that point to the non-representative point is nearer, then you replace your non-representative as representative and whatever you have considered as the representative, you change that to the non-representative. Indukante I'll do one thing. Just that. Yeah. Say, for example, now if you take this as 1 point, yes. Are you able to see this one? Just one of you say yes or no. Yes, okay. Now, what we will see here is you take this as the representative point, okay, and this as the non-representative point. This as my point P, just for example, this is my point Now what you have to do is find out the distance from this point to yes. So you find out the distance from this point to the distance. What we think is, because this is the representative point, we think that your E is nearer to this R, representative point. What is that we have to do here is to again find out the distance from this P to this non-representative point also. So this is your non-representative point. Your R is, yes. Now we think that your P is nearer to R, but what you have to do is you find out the distance from P to this NR, non-representative also. If you find that this P is nearer to non-representative point, if you find, say for example, if, yeah, obviously if you see the picture here like this, so if you see like this, we think that your P is obviously nearer to non-representative point. Now, if you find the distance, if the P is nearer to NR, then you change the representative point of P to non-representative point. But if you find that your P is nearer to representative point only, you need not change. You just keep the representative point of P as it is as R. Only if you find that the distance of your non-representative point is nearer to P, now you change that representation from this red to orange. This is what your k-medoids, which you have to do for each and every points in the database. So for every point, you find out whether this is nearer to this or non-representative is nearer. So whichever points are nearer to this, you take, for those points, you take that as representative and change this one as non-representative. Are you clear with the example, with this example? Why we have to do all this is the final thing, this distance from that PI to the representative point OI, I want that distance టు బి రెడ్యూస్డ్. అంటే దగ్గరగా ఉన్న పాయింట్స్ అన్ని, అంటే ఫర్ విచ్ ద ఆబ్జెక్ట్స్ డిస్టెన్సెస్ ఈజ్ లెస్, ఐ వాంట్ దట్ డిస్టెన్స్ టు బి ఇన్ ద క్లస్టర్. సో ఫైనలీ ఏంటి అని అంటే, ఇఫ్ ఐ టేక్ దట్ ఒకటి అనుకుంటున్నాను బట్ ఇంకొకటి దగ్గరగా ఉంది అని అంటే, సో విచ్ మీన్స్ దట్ ఈస్ ద ఎర్రర్. అంటే ఆ డిస్టెన్స్, ఇఫ్ యూ టేక్ దిస్ హియర్ అండ్ సే ఇఫ్ I think that though this is nearer, I think that this is ఇది దగ్గరగా ఉందేమో అని అనుకొని ఇది రిప్రజెంటేటివ్ అనుకుంటున్నాను. బట్ ఇఫ్ ఐ చేంజ్ దిస్ వన్, ఇఫ్ ఐ చేంజ్ హియర్ టు హియర్, ఆబ్వియస్లీ మై డిస్టెన్స్ ఫ్రమ్ దిస్ టు దిస్ విల్ బి రెడ్యూస్డ్. అంటే అది ఎర్రర్. ఇంత డిస్టెన్స్ ఒక 6 పాయింట్స్ ఉంది ఇక్కడికి ఇక్కడికి, అండ్ అక్కడ నుంచి ఇక్కడికి 3 పాయింట్స్ ఉంది, ఆర్ సే 2 పాయింట్స్ ఉంది. సో విచ్ మీన్స్ 4 పాయింట్స్ ఐఎమ్ ఇన్ ద ఎర్రర్. అంటే ఇది రిప్రజెంటేటివ్ అని అనుకోబట్టి 4 పాయింట్స్ ఆర్ దేర్ ఇన్ ద ఎర్రర్ సైడ్. బట్ ఇఫ్ ఐ చేంజ్ దాట్, మై డిస్టెన్స్ ఇస్ 2 ఓన్లీ. సో ఈ 4 పాయింట్స్ అనేది కన్సిడరింగ్ దిస్, ఐఎమ్ అండర్గోయింగ్ ఎర్రర్. సో బై k middoids, what finally I want is that distance should be reduced. So which I call that to be as error criterion. So what is the objective of your k middoids algorithm is you should minimize that absolute error. నాకు ఆ ఎర్రర్ అనేది తక్కువగా ఉండాలి ఫర్ ఆల్ ద సెంట్రాయిడ్స్, ఫర్ ఆల్ ద పాయింట్స్. దిస్ ఈస్ లైక్ యువర్ p is belonging to the ci, which is the representative point. అన్ని పాయింట్స్ రిప్రజెంటేటివ్ పాయింట్స్ కింద కన్సిడర్ చేయాలి. అండ్ టు ఆల్ ద క్లస్టర్స్, ఎన్ని క్లస్టర్స్ కావాలి k అని అనుకుంటే అన్ని కూడా యూ హ్యావ్ టు కన్సిడర్. So that is the example here we will see in the k middoids. These are the oi and oj. You take them to be as the representative points. Random is one point and p is another random point. ఇప్పుడు p నుంచి distances find out చేయండి. So already your p is under oj cluster లో ఉంది p already, that is the solid line. And if you find that oi ki o random ki ఈ p distance find out చేస్తే, if oi is lesser than the distance from oj, you make your p to go into oi, and after swapping you keep your p to this one. So which means your p is reassigned to oi. This is one case. What is the other case is, instead of oi, now your p is nearer to o random, ఇంకొక పాయింట్ కి దగ్గరగా ఉంది. సో oj నుంచి ఇక్కడ దీనికంటే దీనికి దగ్గరగా ఉంది కాబట్టి దీనికి మార్చండి. Now if you take this oi as a representative and remaining oj and non o random as non-representative here, and if your p is ఈ distances find out చేస్తే, if your p is still nearer to oi, you need not change that one, just keep it like that. Again, if the p is here, oi is here, o random and something like this, then you change that. ఇక్కడ already oi కి దగ్గరగా ఉన్నా కానీ you change that to o random. So your solid line is the previous one, your dashed line is the changed one. This is what your k middoids algorithm is. So that by doing this, we are trying to reduce the distances, and that distance which is default, if you take that to be as nearer to the other point, you have to cut down that distance. So what is that distance? We call that to be as absolute error criterion, and that is what the output of your k middoids algorithm is. So this is what your k middoids is. Just raise your hands if you are in tune with k middoids. I don't know the other people whether they don't know how to raise the hand, or just say just kind of roll call. I'll call some names. Respond to this. Sunila, are you there? Sunila, Abhishek, Tulasi, Pavan, Amulya.
Yes, ma'am.
Okay, but
Ma'am,
you raised your hand, but still I don't know, I see you there. Okay. Okay. Yes. Shall we move on to now? Now you have seen two algorithms for your k-means and k-medoids under your partitioning algorithms, under your clustering, which is one of your data mining functionality. Shall we move on to hierarchical clustering? Okay. So the other one, this is what your k-medoids algorithm is. Of course, this also is in English. Just you go through the logic what we have said till now. And this k-medoids, you also call that one as partitioning around medoids, PAM algorithm. The other two methods in the hierarchical methods is where we try to form the trees or the dendrograms we go in the level wise clustering. So the two algorithms here we see is agglomerative and divisive hierarchical clustering, two algorithms. One is, we call that as AGNES, agglomerative nested clustering, and the other one we call as DIANA, divisive analysis. So just with the figures, it is very simple. If you see this one, both algorithms will be in the same picture only. AGNES, the simple step you consider is, you consider each object to be as a cluster initially. In the first round, in the first iteration, you consider each object to be as a cluster. Now taking any similarity measure, now in the second step, you form a cluster by combining the previous clusters if they are similar. Ante in this step, in the second step, if you find the distance from A and B is similar, you form these two clusters into another cluster. You are trying to integrate the individual clusters into another cluster. Now in the second step, you have observed D and E are similar. So in the second step, DE into another cluster. Similarly, in the third step, you observed DE and C as similar. So these two will form one cluster. And in the step 4, you observed AB and CDE into another cluster. So finally, all these objects in stepwise, starting initially from the individual clusters, have formed one cluster. Exactly opposite is your DIANA, which is a divisive analysis. This is exactly opposite. Initially, you take all the objects into one cluster. Find out the dissimilarity measure, the dissimilarity between all the objects. So here, whichever objects are dissimilar, you break them. So in this cluster, CDE finds to be dissimilar from AB. Now again, apply the same method from CDE. Next, in the second iteration, DE finds to be dissimilar than your CDE in the complete cluster. Now again, in this step here, AB finds to be dissimilar. And again in this step, these all finds, or they all fall to be into another individual clusters. So that is why they all have come into individual clusters. So divisive and AGNES here, they are like totally opposite logic of forming the clusters and dividing the clusters. The same example here we can see, with which we also call this as dendrogram representation, which is nothing but your tree structure. You can form in this way, or you can tilt this tree also the other side upside down. Now if you take all these objects in the first step here in the level 0, The similarity scale, if we take on this side, so AB we have formed in level 0 itself, and again in the step 2 we have formed DE, which is your level 2. This is with the similarity scale here, and similarly we have formed this part CDE in the level in this level 3, and in the level 4 we have combined these two. This is what a dendrogram representation for hierarchical clustering of your data objects. Um, this is like a single linkage approach, because individually we are linking individual objects and then individual clusters we are linking, and this is what your representation goes. Groups of objects, it is like if you say this similarity between AB and similarity between CDE. See the similarity scale here. If you take the AB, the similarity scale it is going here is zero point 0.8, and if you take this similarity scale it is coming around somewhere around 0.7, and the CD it is coming around 0.4. Now if you add all this, zero point 0.4 plus 0.6 and again 0.8, so it is coming around 1.8 something. So the similarity scale at 1.8, you are forming the dendrograms of this and this particular these two we are forming. That is what you scale in your similarities and form the clusters in the this part, Agnes and Diana. These are the simple clusters you can form with your uh, hierarchical clustering, and you can write the same steps when you go for algorithm also. In case if the algorithm is asked, you can write the same steps how to write this one. Yes, as we have seen, like distance measures in algorithm methods, you can even find uh, your algorithms distance measures in the sense you can find instead of the mean and the average distance, you can find the actual distance as Euclidean distance, and Manhattan distance you can find those two algorithms. Burke we are not going, only you can stick on with divisive and Agnes. Those two algorithms you can stick on. Burke is a kind of similar to your dendrograms, but we are not going to see this one. And what we are left over with is your density based scanning algorithms. This is also your Chameleon and hierarchical. Only two methods, simple methods we are seeing. So the next one we will see is density based clustering. So before we see the DB scan, initially we will see what this density based is. So if you have the objects in this way, where they are having many objects into different kind of shapes, and where we almost trying to predict the shape of the cluster, and some objects are somewhere here, and where these objects are crowded at one particular point, then we will go for density based clustering based on connected regions with high density. These are all with high density, highly crowded, highly populated. Now, with this, for this algorithm, we have one density based clustering or density based scanning algorithm, spatial clustering of applications with noise. So we find these points which looks like as outliers, we call them as noise here. The full form of this your density DB scan is density based spatial clustering of applications with noise. Spatial clustering of applications with noise. We generally use this algorithm for spatial data mining, where to find the distances from this point to the other. Now in this algorithm, in the DB scan, 3 points you have to consider. The first one is epsilon neighborhood. This is what your epsilon neighborhood. The other concept you should know is the minimum points. Minimum points, epsilon neighborhood and the minimum points. And two terms you should know is density reachable, indirectly density reachable. Density reachable and indirectly density reachable. Two parameters and two concepts. So with direct example, and then we will come back. If you see this particular data set, so this is the complete rectangle is your data set, and we need to form the clusters here. So initially what you take is all the points in this are unvisited. You did not visit any of the points. Now you take initially one point and mark that to be as visited. When you will mark is, say this is the P point randomly or initially I have taken. Now taking this point and this as the center with the epsilon value, whichever is taken as the epsilon neighborhood, we call that as epsilon neighborhood. Say for example, my radius is 3, that you take that radius for time being as 3, and with that radius taking this center, form one circle. And after you form the circle, and either on the circle or inside the circle, if you find there are minimum points in that circle, if you find there are minimum points, where that minimum points I have mentioned in the beginning, you treat that if there are minimum number of points are there, you treat that to be as the core object. Now again I repeat. Now say for example, if this P I have taken randomly and my epsilon neighborhood is value is, say for example, epsilon neighborhood is some 2 radius, say 2 radius. So in that 2 radius, I have drawn one circle, and if my minimum points is say 3 objects, minimum points is 3 objects. Now considering this P, in this circle total 4 objects are there. But what I need is minimum 2 I should be are there. Minimum points, what I want is 2 objects. So here, because there are already 4, your P becomes your core object. So your P now becomes the core object. When your P becomes a core object is, if you draw a circle taking that P as the center, where the radius of the circle is equal to epsilon neighborhood, and in that circle, if you have the minimum number of objects is equal to or greater than the minimum points, then you call that P to be as your core object. I hope you are with me. So what is that we are giving here is, yes. So in your DB scan, what is that we are specifying initially is, you should tell what is your epsilon neighborhood value. This is one. And you should tell what are the minimum points you want, and you should tell what is your core object. You should tell whether it is density reachable or not, whether it is indirectly density reachable. These are the 5 points you have to remember in your DB scan algorithm. And 1, 2 will be your 1, 2 will be your inputs. Core objects will depend on this input, and you should finally say whether they are density reachable and indirectly density reachable. If this is the case, if the points are density reachable from your core object to the point what you consider, then keep that in the cluster. Even if it is the indirectly density reachable, also keep it in the cluster. If not, you need not define that point into that cluster. అది కనుక లేదు అని అంటే you need not define. Now we will see how to form this is, because minimum points here I have taken here as 3. Just for example, the input here it is given yes. The minimum points here I have taken to be as 3, and epsilon neighborhood is some radius, and draw one circle with that. Now, after that your M is on the circumference of this circle, because this is the core object. Now, because check whether P has become the core object or not, because total you are having in this circle 4 objects are there. Now your P is qualified as the core object. Now take this M, because this is the core object, whichever point lies in that circle, take that as the center, and again epsilon neighborhood as the radius, draw the circle. So now if you draw this, check whether M is core object or not. So if you take M, now this in the second circle, total 1, 2, 3, yes, 4 objects are there. No, 4 into 5. 5 objects are there with M as the center. See, 1, 2, 3, 4, and inside 5 objects are there on this circle. Obviously, now M is qualified as the core object. Now find out whichever points are there on this circumference and draw the circle with that same radius. Now this is the circle, and your Q has come as the center, and if you take this as the circle and Q as the center, and total we are having only 2 objects. So because 2 objects have come, your Q is not qualified as the core object. Q is not the core object here. So because your Q is not the core object, you stop drawing the further circles from the Q as the center. ఇప్పుడు Q ని సెంటర్ కింద తీసుకొని సర్కిల్ డ్రా చేయడానికి లేదు, because your Q did not qualify as the core object. Now the total, this complete circumference will become one cluster. This is what your DB scan algorithm is. Similarly here, if you take taking this O as the center, drawing the circle, and again if you keep on going like this, you draw like this, and which are density reachable, which are indirectly density reachable. So from P to M it is density reachable, M to Q it is density reachable, whereas P to Q it is indirectly density reachable. So indirectly density reachable means from P to Q, because M is there, and from M you are able to reach to Q. So this is P to Q you can go, but you cannot come from Q to P, because this part Q is, because Q is not the core object, you cannot come from Q to P, but you can form whichever are indirectly density reachable also as the cluster. Similarly, this part, this is another cluster you form. So this will be one cluster, this will be one cluster. This is what your DB scan algorithm is. So only the thing here you have to see here is whichever considered as the core and draw the circle, then it becomes the visited. Whichever are not taken as the center to draw the circle, they are the unvisited. So you can make all the unvisited as the visited, provided that object becomes the core object. This is what your epsilon neighborhood tells about your P. They are added as the candidate for your cluster, and you can keep on going like this. What is the time complexity your DB scan takes? This is your DB scan algorithm is. This is somewhat your algorithm structure. You tell what your this algorithm input and output. As I said, like the epsilon, the radius parameter, and minimum points, and your data set. The complete these three are your input and the set of density based clusters. So randomly we take any object, mark P as visited, and if the epsilon neighborhood of P as the minimum least points, as the least minimum points, then create a new cluster and add P to C. So you keep on adding your P to C, and whichever points are in that epsilon neighborhood, P dash neighborhood, they are in that circle, which is like your P dash here is the example as M. Now P dash, which is M as unvisited, mark P dash as visited if the epsilon neighborhood has least minimum points. This is nothing but if the epsilon neighborhood of P has the minimum least points, means this is nothing but your P dash is the core object. This is nothing but means your P dash is the core object. If it is the core object, then add those points to your cluster points. So this is what the complete thing. If any of the points does not fall into that, the core object, you mark that P as the noise one. So noise in the sense that is as the outlier. So you have to keep on do all these things until no object is unvisited, which indicates that every object is visited. So whether you, if after you visit, whether this becomes the core or not, you have to see. So if it has the minimum points and all, you can add that to N. If not, if P naught is not yet a member of any cluster, add your P dash to C. That is what your DB scan algorithm is. Mm, Just raise your hands if you understood the DB scan algorithm, which comes into your density based clustering. And Prasad, where are you? BVVSV Prasad, Unnava? Hmm. ఓకే అండర్స్టాండ్ అర్థమైందా డీబీ స్కాన్ అర్థమైందా ఎక్కడో లోగా వినిపిస్తుంది ఐఎమ్ నాట్ ఏబుల్ టు లిసన్ యువర్ వాయిస్ 17 more have raised their hands. Okay. Okay. The next algorithm we will see here is optics. So the optics algorithm here, the basic concepts and your we try to overcome the drawbacks of DB scan in the optics, which indicates that input parameters we have to give, which is epsilon and the minimum points. Like we are setting those points and we are indicating. So because of that, without giving the minimum points, without giving any number of minimum points, we can form the clusters. That you will see in these ordering points to identify the clustering structure. Ordering points, which is you call that as optics. This also into density based clusters. Another algorithm is optics, ordering points to identify the clustering structure. This is similar to DBSCAN but with a different methodology. Directly we will go to the example and then we will come back to this one. In this you have to have again the epsilon value, and two things you should know is core distance and the reachability distance. The core distance is nothing but, see, if you take this point P and if you form one circle and epsilon neighborhood is the one 3 millimeters we have taken, that becomes the core distance of P. The core distance of P is that. How to form the clusters of this optics? ఈ optics నుంచి clusters ఎట్లా form చేస్తాము అని అంటే, before you form the clusters here, now see there are two, epsilon and epsilon neighborhood. So this is epsilon value is 6 and epsilon dash, or we call that as epsilon neighborhood, we call that a epsilon dash, which is 3 mm. And whichever points falls within that epsilon neighborhood, you say that your P is in the core distance of these. All points are in the core distance of this. The other thing you have to see here is, what is the reachability distance of P? What is the reachability distance of P? Now if you take the distance from P to Q1, P to Q1, whichever is maximum, you take that distance. So from P to Q1 is one distance, and from P to your epsilon value is another distance. అంటే P నుంచి epsilon value ఒక distance, that is అంటే default minimum value ఏంటంటే 3 mm, అండ్ ఈ Q1 చూస్తే ఏంటంటే ఇంకా మేబీ దిస్ ఇస్ లైక్ 1.5 ఉన్నట్టుంది, 1.5 డిస్టెన్స్ ఫ్రమ్ P టు Q1. ఈ రెండిటిలో వాట్ యూ హ్యావ్ టు టేక్ ఇస్, విచ్ ఎవర్ ఇస్ maximum, take that as the P's reachability distance from that to this. So reachability distance from P to Q1 ఏంటంటే ఈ వాల్యూ ఇస్తారు, నాట్ దిస్ వాల్యూ. మినిమం కాకుండా ఈ కోర్ లో ఉండే వాల్యూ ఏదైతే ఉందో ఆ వాల్యూ అంటే మాక్సిమం. ఈ రెండిట్లో మాక్సిమం ఏదంటే అంత వాల్యూ, అంటే అంత డైరెక్ట్లీ డెన్సిటీ రీచబుల్. సిమిలర్లీ ఇఫ్ యూ టేక్ ద Q2, now which distance is lesser from P, either with the core distance or the distance from Q2. అంటే కోర్ డిస్టెన్స్ వచ్చేసేమో ఎప్సిలాన్ వాల్యూ విచ్ ఇస్ 3, అండ్ ఇక్కడికి వచ్చేసరికి ఆల్మోస్ట్ 5.8 or 5.9 ఉంది. సో దిస్ డిస్టెన్స్ ఈజ్ maximum. So your P is reachability distance now, which means that your P is reachability distance to Q2 than your epsilon. Maximum ఏదైతే ఉందో ఆ వాల్యూ ఇక్కడ ఇచ్చేస్తారు. సో ఇక్కడ ఎందుకు reachability distance P, Q1 3 mm ఎందుకు ఇచ్చారంటే this is the maximum. Reachability distance from P to Q2 is given as P, Q2 because this distance is maximum than your core distance. Core distance కంటే కూడా ఇది ఎక్కువగా ఉంది. సో ఈ పాయింట్ P కింద Q2ని కూడా ఈ క్లస్టర్లో కలిపేస్తారు. సో దట్ ఈస్ వాట్ యువర్ క్లస్టర్, ద లాజిక్ ఆఫ్ యువర్ ఆప్టిక్స్. అండ్ లాజిక్ ఆఫ్ ఈ ఆప్టిక్స్ ఒక్కటే, దిస్ ఇస్ ద ఓన్లీ అల్గోరిథం which gives your clusters into circle shape. Whether you take the k-means or density DBSCAN, ఇవన్నీ కూడా ఏంటంటే that clusters will not come into the circle shapes, whereas the optics is the only algorithm which gives as ordered seeds. ఈ ఆబ్జెక్ట్స్ అన్నిటి ordered seeds ఉంచి we call that shape వచ్చేసి circle కింద వచ్చేస్తుంది. Now we will see what are these 2 points here in the optics algorithm వచ్చేసరికి. what is the core distance you have to write. What is this core distance means? The smallest value. This is like epsilon neighborhood you can call. Lower ఇది వచ్చేసి density value. To the lower epsilon is one value, which is the 6 we have seen. Smallest ఇది వచ్చేసి ఇంకా కొంచెం తక్కువ ఇదిలో ఉండేది. That is epsilon neighborhood, you call that epsilon neighborhood and on top of p, and which has least minimum points. దానికి ఇక్కడ కూడా డిబి స్కాన్ లానే మినిమం పాయింట్స్ ఆబ్జెక్ట్స్ ఇన్ని ఉండాలి అనేది యూ కెన్ కీప్. సో సీ దిస్ వన్ హియర్. ఇక్కడ వచ్చేసి మినిమం పాయింట్స్ 5 అనేది పెట్టుకున్నాను. ఎప్సిలాన్ వాల్యూ is your 6 mm and epsilon neighborhood is my 3 mm. Always your epsilon neighborhood should be less than your epsilon value. ఇది వచ్చిన తర్వాత ఈ వాల్యూస్ మనం ఇచ్చుకోవాలి. And then how to find the reachability distance. Reachability distance, as I said, it is nothing but the maximum of either the core distance of the Q or the distance from P to Q. ఇప్పుడు నేను Q నుంచి పీకి వెళ్ళాలి. Q నుంచి పీకి వెళ్ళాలి అని అంటే కోర్ డిస్టెన్స్ ఎక్కువగా ఉందా, ఈ డిస్టెన్స్ ఎక్కువగా ఉందా, ఈ రెండిట్లో ఏది మ్యాక్సిమమో అది తీసుకుంటాను. ఇవన్నీ తీసుకొని దెన్ ఐ ఫార్మ్ ద క్లస్టర్. సో ఎట్లాగా ఫార్మ్ చేస్తాను హియర్, యూ హ్యావ్ టు గో ఫర్ ఆర్డర్ సీట్స్ ఈజ్ ఎంప్టీ. ఇక్కడ ఏంటి అని అంటే యూ కీప్ ఆల్ ద ఆబ్జెక్ట్స్ ఇన్ టు ఆర్డర్ సీట్స్. అంటే జస్ట్ నథింగ్ బట్ యూ టేక్ దిస్ ఆర్డర్ సీట్స్ టు బీ యాజ్ ఎన్ యారే. అంటే ఇక్కడ లిస్ట్ లాగా పెట్టుకున్నాడు. అంటే ప్రోగ్రామ్ రాసేప్పుడు యూ టేక్ దిస్ లిస్ట్ టు బీ యాజ్ ఏ యారే విచ్ ఎవర్ ఆర్ నాట్ ఇంకా కన్సిడర్ చేయనివి. ఈ కన్సిడర్ చేయనివన్నీ కూడా ఒక యారేలో పెట్టేసుకొని ఈ ఆర్డర్ సీట్స్ ఎంటీ అయ్యే వరకు కూడా ఈచ్ అండ్ ఎవ్రీ వన్ ఇలా కన్సిడర్ చేస్తూ ఈ మ్యాక్సిమం డిస్టెన్స్ లోపు కనుక ఉంటే యూ టేక్ దిస్ టు బి యాజ్ ద క్లస్టర్. ఈ ఈ ఈ ఈ సర్కిల్ మొత్తంలోకి ఉంటే చూడండి. లేదు, ఇఫ్ ఎనీ ఆబ్జెక్ట్ ఈస్ ఫాలింగ్ హియర్, బయట ఇక్కడ ఏమన్నా ఉంటే ఈ ఎప్సిలాన్ వాల్యూ కంటే అది బయట ఎక్కువ పడిపోయింది కాబట్టి యూ దీంట్లో ఉన్నవే యూ కన్సిడర్ యాజ్ పి. యూ క్యాన్ డెన్సిటీ రీచబిలిటీ డిస్టెన్స్ ఉన్నవే క్లస్టర్లో ఫామ్ చేయండి. రీచబిలిటీ డిస్టెన్స్లో లేనివి యూ క్యాన్ సెండ్ ఇట్ ఇన్ టు ద అదర్ క్లస్టర్. దిస్ ఈస్ వాట్ your optics algorithm is, which is the second algorithm in your DBSCAN density based algorithms, ordering points to identify the clustering structure. Let me see your, yes. So if you take all this, we have seen 4 different types of clustering, and in that we have seen three types, and in that 3 types, two algorithms we have seen. So in the partitioning algorithms you have seen k-means and k-medoids. Hierarchical algorithms, divisive and Agnes you have seen, and in the density based DBSCAN and optics algorithms. 6 algorithms you have seen in the clustering concept, and this is one of your data mining functionality. Yes, any other doubts you have?
No, ma'am.
Okay, Amalya. Yes. MCA Rajahmundry, I think you can leave. Kakinada campus, what else we have to see? You better all of you come to class tomorrow from maybe 9:30. I will take the class, last class. Whichever topics are left over, I'll complete all of them. I think almost all we have cleared. Did we complete the back propagation algorithm in the classification? Back propagation?
No, ma'am.
Okay. Basin is over, right? Basin classification is over. Did I complete basin classification?
No, ma'am, not yet.
Oh. Tomorrow we will see basin classification and back propagation so that we.
Even support vector machines also, ma'am.
Oh, SVM is there, right?
Yes, ma'am.
Okay, I think for SVM also we will complete tomorrow. About Rajahmundry, I think SVM is over for you. I was told that classification is over for you. So I think I have taken. I don't know anyone in the Rajahmundry to call you out by your names. I don't know. Anyway, yes. Yeah, Kakinada camps. We will meet tomorrow. Okay.
Okay,
See
ma'am.
you all.
Thank you,
If
ma'am.
you have any doubts, you can raise in tomorrow's class. Yeah, you can leave this one.